Okay, so let us discuss what is acceleration. So now, acceleration is the name we give to any process where the velocity changes. Since the velocity is a speed in direction or magnitude in direction, that the rate of change of the positions, there are only two ways for you to accelerate. It's either change your speed or change your direction, or it can be changed both. No, if you're not changing your speed and you're not changing your directions, then you simply cannot be accelerating no matter how fast you're going. So when the velocity of a particle changes with time, so the particle is said to be accelerating. So just like, for example, here the magnitude of car's velocity increases when you step on the gas, no, and decreases when you apply the brakes. When you step a gas, mo change yung velocity, so natay acceleration. And when you apply brakes, so nagyapoy mo acceleration. Di na siya matawag acceleration, which is deceleration. Okay, so let us see how to quantify acceleration. Suppose this object, no, that can be modeled as a particle moving along the x-axis. It has an initial velocity with a time ti at position, and a final velocity vxf at a time tf at position. So we can represent this behavior of the acceleration of this car by representing Vx time diagram. Okay, so let us say that this is our curve, no, nga na-create when this uh, car moving or changing the velocity of this car, no. So the red brown curve here shows how the velocity varies with time, no? So here, so we have, so uh, the slope of the blue line connecting A and B is the average acceleration of the car during the time interval, no, change of t is equals to tf minus ti. Okay, so this one here from A to B is kuha niya acceleration with the entire acceleration from A to B, no. Okay, in this interval change of t. So this green line here, the slope of the green line is the instantaneous acceleration of the car at a point B, no? With a gikuha po ni nato diri ang kaning slope ani. So ang makuha ani nga acceleration is our resulting acceleration with the specific instant of time, which is the t final nga position. So we can also get the instantaneous acceleration here from our a, no, we varied this time, initial time. Okay, so the average acceleration can be calculated of the particles defined as the change in velocity delta vx divided by the time interval change of t during which the change occurs. So it can be formulated as using the delta vx over delta time. So this one here is the same process, no, pagkuha sa velocity of average velocity. So we have Vx. So sa average velocity is ang gigamit natong pagkuha is we are using the position, the delta, the changing of the position. Here is the changing of velocity, which is the final velocity and minus the initial velocity with respect to interval of time nilang. So we have t final minus t initial. Okay. So in some situations, the value of the average acceleration may be different over a time interval. It is therefore useful to define the instantaneous acceleration as the limit of the average acceleration as change of t approaches 0. So instantaneous acceleration or acceleration at a specific instant in time is obtained using the same process discussed for our instantaneous velocity. That is, we calculate the average velocity between 2 points in time separated by change of t, and let our change of t approaches to 0. So we have also using the definition of our limits of a function. So the result is the derivative of the velocity function or the rate of change. So here the delta Vx over delta t is we also call the rate of change, which is the dvx over dt. Okay, or which is instantaneous acceleration can be also expressed in mathematically as the dvx or over the dt. So this figure below shows how an acceleration time graph is related to a velocity time graph here. The acceleration at any time is equal to the slope of the velocity time graph at that time. So the acceleration at any time equals to the slope of the line tangent to the curve of Vx versus t at that time. So when we representing the acceleration time graph, so we usually it's a matter of how the rate of change sa slope here in our velocity time graph, so kung unsa atong unsay degree nga slope ato ang na-create from vxt or velocity time graph, so magmatter gid siya sa ato ang acceleration time graph, so as we increase the magnitude of velocity going to maximum velocity, ang may tabuan na sa atong acceleration is mo decrease pod, going to when the velocity is sa maximum level. So ang atong slope diri may tabo sa atong what happened to our slope here is mahimo na siya og horizontal line, or atong degree of slope diri is 0 na. So kung 0 ato ang slope, kung ato na i-represent sa ato ang acceleration time diagram, so ang may tabuan na is ma-0 sa diyang magnitude of acceleration, diba? So sa ato ang definition, So the acceleration at any time is equal man the slope of the line tangent to the curve of Vx versus time at that time. Okay, so at this maximum level of velocity, so since uh, naa naman siya sa horizontal line, no? And na iyang slope diri is 0 degree naman. So ang mahitabo sa atong acceleration is ma-zero po. So that's how we interpret using the in relation with the velocity time graph and acceleration time graph. So let's have sample problem 1. So the velocity of a particle moving along the x-axis varies according to the expression. We have here the equation Vx is equals to 40 minus 5t squared, where Vx is in meters per second and t is in seconds. So A, find the average acceleration in the time interval t is equal to 0 to t is equal to 2 seconds. So we have also here determine the acceleration at t is equals to 2 seconds. So for the solution of A, find the average acceleration in the time interval t equals to 0 to time equals to 2 seconds. So let us first graph unsay behavior sa ato ang ato ang curve no nga gi present here. 40 minus 5t squared daw ang motion, particle moving along the x-axis. So ingani ang mahitabo no kung ato ni i-graph ang atong 40 minus 5t squared nga equation. So ang pangutana is find the average acceleration with this interval time no. Unsa na to pagkuha? So first is let us calculate the initial velocity with a time t is equals to 0 using the equation that we had from the problem nga gi present na to niya, which is 40 minus 5t squared. 40 minus 5 times 0 squared is equals to positive 40 meter per second. And we can also calculate the value of velocity here at B, no? So using this time, which is our final time, that is equal to 2 seconds, so we can get the value of Vxb, that is equals to positive 20 meter per second. Okay, next we have to calculate the average accelerations using the equation that formula that we discussed before, that is Vxf minus Vxi over Tf minus Ti, or it can be represented also in terms of A and B, no? So Vxb minus Vxa over Tb minus Ta. So now naa naman tayo mga value for Vxa and also for the Vxb. So we can direct substitute no say value ani. We have 20 minus 40 over the 2 seconds, which is our t final, and minus 0, which is our initial time. So we can get the average acceleration, which is negative 10 meter per second squared. Now, for V, determine the acceleration at time equal to 2 seconds. we know that pagkuha sa itong velocity final is that ato ang time ana is ni change no from the initial nga time, di ba? So we have t plus the changing of t. So that's our final time. So t plus change of t. So in order to get the vxf, so mo ni ato ang time ni time plus change of t ang i-required equals to 40 minus 5t squared. So kung ato ni expand pa, ay mo siya og 5t squared minus 10t change of t minus 5 change of t squared. So if we going to calculate the delta vx, no, which is the difference of the velocity final minus the velocity of initial. So since our vxi, so it only the equation ana is in terms of 40 minus 5t squared raman. So kung ato na i-minus, so makancel out yung kanino 40 minus 5t squared. So ang may bili na lang is ang kaning equation negative 10t change of t minus 5 change of t squared. Since that our define what are trying to looking for is pagkuha sa instantaneous acceleration with a specific time to t is equals to 2 seconds, no? So we can also, after this, we can use the concept of limit of a function, no? So that we atong discuss before, we have acceleration x, limit change of t as approaches to 0, change of vx over change of t. Okay, then so na naman tayo change of vx, no, with respect to time here. So pwede na nato na ma-substitute as change of t approaches to 0. So here, so ma-cancel out, ano? So ang may bili na lang is negative 10t. Okay, so at time is equals to 2, negative 10 times 2, that will be equal to negative 20 meter per second squared. So we can also use the derivative nga operation, no? Since ang ato ang definition for the limit is equal man po na sa derivative, no, derivative of a function. So kung ato ni derivative, ang vx is equals to 40 minus 5t squared. So mo ra gyapon ang result sa equation, no? Since kani ang constant nato is ma-0 man, ma-derivative siya ang function, then kani siya is gamit ang power rule, ay siya negative 10t. So mao gyapon, no? At time is equals to 2. So your instantaneous acceleration is negative 20 meter per second squared. Okay.